Hi, everyone, and welcome to today's webcast on machine learning with the Google Cloud Platform, or GCP, if you will. I'm glad you could join us. Let's take a look at what we'd like to cover over the next 30 minutes or so. We'll start with some high-level introductions to ourselves and to Thoroughgood. We'll then take a few minutes to introduce people to the Google Cloud Platform as a whole, for those who aren't quite as familiar with the platform. Also, since we're talking about offerings within the ML space in GCP, we figured it'd be helpful to kind of lay out what a typical data science process can look like to understand how these offerings in the ML space can help. From there, we'll dive into the main machine learning service within GCP, which is called Vertex AI. We'll get to see that in action today, and we'll also wrap up with some key takeaways and some considerations for getting started. Right. So with that, I mentioned some brief introductions. My name is Scott Stieritz. I'm a data and analytics consultant with Thoroughgood. I'm joined today by my colleague Harpreet. Harpreet and I are both very interested in everything within the ML space. We're both pretty excited for the content that we have prepared for you today. So as far as Thoroughgood as a whole, who are we and what do we do? We are an independent data and analytics specialist consultancy. We operate primarily within the data engineering, data science, and data visualization space in that data and analytics industry. And what that means is that we offer everything from strategy services to high-level architecture design and implementation to specific solution design and development, hands-on advanced analytics services, user empowerment, training, adoption, support, kind of everything across the breadth of that data and analytics space. We're a global organization, so the company is based out of London. We have two offices in the US, in Philadelphia and Boston. The US offices are where myself and Harpreet are based, and we also have other offices throughout the world in Singapore, in Sao Paulo, and in Bangalore. We are an independent consultancy, meaning that while we partner with many of the leading technology providers within the data and analytics space, we're not tied to one specific tool or one specific platform. I've put up on the screen just now a few of the technologies that we work with, kind of many of the leaders within that data and analytics space. And this independence on our end allows us to understand an organization's technical landscape, maybe strategic objectives, understand the key business objectives for a specific solution, and kind of share an unbiased perspective on the ideal technical landscape for that solution, given all those parameters. It also allows us to stay up to date with technology updates across the industry so that we can develop robust, modern solutions for our customers. So like I said, we'll keep the introduction short. We'll now go into an overview of the Google Cloud Platform as a whole. So as you could probably guess from the name of Google Cloud Platform, it has its origins in the founding of Google, which was in 1998. I'm sure I don't need to explain to those on the call what Google does, but you can imagine Google is good with data. It's kind of the essence of what they do. And we can look at the Google Cloud Platform as the packaging and the commoditization of this expertise in data that's been built over the years through Google. In around 2008, so about 10 years after Google was started, Google made available this offering called the App Engine, which was focused on development and deployment of custom web applications. Over the following few years beyond that, the App Engine kind of evolved. It got ready for general availability in about 2011. In the meantime, some of the other key services within the Google Cloud Platform started to be released, like cloud storage, some of the compute services as well. And then that takes us all the way to today, about 10 years after that, a little over that, at which point GCP has well over 100 unique services continuing to grow, continuing to develop, and distributed globally. So availability throughout the world across a number of different regions. I've put up on the screen probably something that line by line is not that helpful of a visual, since it's pretty big, a lot of information on it, but I think is useful in highlighting the breadth of offerings that are available within GCP. We have everything that's We can see everything from like the more infrastructure as a service focused offerings like compute and storage, some instances to things a bit more focused on data and analytics in particular. We have some niche offerings. So I'm sure people are familiar with Google Maps. There's a ton of APIs, SDKs, assorted offerings related to Google Maps. So kind of the breadth of what you might be interested to do related to data is available within here. We can see this big section down at the bottom and continuing into the top here. This yellow section focused on AI and ML. And we can see Vertex AI as a tool that, or many of the functional or pieces of functionality within that tool that spans this space, which I think gives a sense for the breadth of what Vertex AI brings to the table. And also just looking at this header as a whole, the focus that GCP has put in the AI and ML space. So a lot to cover, definitely more than what we'll have time to cover today, but we'll at least start with getting to see some of those tools in action. I mentioned that in order to understand the value of some of these tools, it's helpful to take a quick look at, independent of tools, what the data science process can look like. So we'll often start at business understanding, an understanding of the business challenge or opportunity or key questions that need to be answered, and move from there into data understanding, kind of a gathering of the knowledge of what data do we have within our organization, how is it organized, where does it live, how might it be brought together, and move quickly from there into some exploratory data analysis, which might be running some summary statistics on the data, might be like noticing some correlations within the data, just some quick high-level exploration of the data, seeing how it fits together, and starting to get a sense for how appropriate that data might be in terms of answering those key business questions that we've identified. And sometimes this part of the process needs to be iterative within itself as we learn more about the data. That might evolve our understanding of how well we can answer the question or what else we might need. We'll then move into data engineering. So bringing that data together, building out pipelines in order to bring the data in from across a number of different sources, join it in the right way, kind of build out the data sets that we're going to need, as well as some additional like feature engineering that we may use within the specific machine learning model. And of course, the modeling aspect as well. So deciding what family of models we're going to need, deciding the specific model. So like model selection, feature selection within that model, training of the model, tuning hyperparameters, all those sorts of activities. Once we have something that's kind of built as far as a model, we'll want to understand how well that performs. How well is that answering the initial question, which might be like understanding the actual performance of the model. It might be understanding like accuracy of the model, any of those sorts of things. And again, this part can be iterative. While we may arrive at something we're very happy with in the first instance, certainly not always the case. We might need to revisit how we're approaching it, change the shape of the data that we're bringing in, bring in more data, engineer more features, maybe bring in some external data sets that we hadn't considered before. So a lot of iteration that can go in here. And hopefully at some point we get to something that's valuable to share out with the rest of the organization where we get to deployment. So this would be, taking what we've built during this initial exploration and training and getting it into production so that it can be shared with the rest of the organization. But we don't want to just end there. We don't want to deploy something and never look at it again. We want to make sure we have robust MLOps practices surrounding any deployed models. So things that will monitor our models to make sure that performance is consistent from an infrastructure perspective, from an actual like model accuracy perspective, as well as build out some things that we might do when that changes. So retraining pipelines or identifying like scalability that needs to happen within compute. So especially for an analytics environment in which data science processes are kind of spread across disparate tools, we can see a number of challenges that come up within this process. One of these is around notebooks. So notebooks are awesome. They're great for EDA or exploratory data analysis, great for experimentation, model development, kind of an intuitive environment for experimenting, kind of storytelling, but it can cause some challenges especially when those notebooks are run locally or when they're not part of a wider MLOps pipeline. Those familiar with notebooks would probably know that they can run cells in any order. You can overwrite cells while objects are still held in memory. Results, of course, are dependent on that order of execution. So it can introduce some reproducibility issues. It can be challenging to know as we're trying to productionize what we're grabbing. Are we grabbing the right code, migrating it in the right way? So how do we integrate that into a productionized application? Another challenge is with compute scalability. So what might be appropriate infrastructure for initial exploration and development might be out of sync with the needs of a productionized workload. And that might mean productionized data volumes. It could also just mean productionized model consumption or like audience demand for the outputs of this model. And that challenge kind of leads directly into challenges with consistency across environments. So as we move from exploration to production, how are we ensuring that we have the right dependencies, the right versions of languages, packages, and libraries, even of underlying operating systems? And if these things can change, how are we ensuring consistency of results? And finally, as we're working across kind of disparate tools and disparate environments, that can put a lot of responsibility on our teams to build processes for monitoring, processes for retraining deployed models, and can even cause challenges with knowledge transfer across teams if there are kind of siloed areas of responsibility. So as the challenges increase, the difficulty of working within these environments increases as well, which leads us to the big question, which is how can we make the life cycle from early exploration and experimentation through to robust productionization and monitoring much easier and much more intuitive for our teams? And we found that working in a unified machine learning platform, which is the nature of what we're going to be talking about today, can help to solve many of these challenges. So that leads us to Vertex AI, or GCP's primary machine learning service offering, through which teams can navigate the full data science process. So at this point, I'm going to hand it over to my colleague Harpreet, who's going to take us through functionality within Vertex AI that can help to address some of those challenges we've just discussed, as well as give us a peek at Vertex AI in action.
As Scott has mentioned, we have some common data science challenges to overcome, and we need a service that encapsulates the different stages of our data science lifecycle. So this is where GCP Vertex AI is like a great solution to address that challenge. It brings all of its ML offerings under one platform. So we'll go on and take a look at some of the key features that Vertex AI has to offer. So the first is cloud storage and BigQuery. So cloud storage is GCP's storage on the cloud. So we can access that, as well as BigQuery, which is just a cloud data warehouse. So it's very easy importing your data, connecting to your different data sets within GCP. The next is a Vertex AI feature store. So the Vertex AI feature store, it comes built in within GCP, and we can use it to serve and reuse features. So the primary goal of a feature store is if you're doing complex transformations on your features, you can go ahead and you can save those transformations and those transformed features in a feature store. And then if you're looking to build a different type of model using the same data, or you're looking to do some sort of similar transformations to different data sets, or if you want to reuse the features for a different problem, you can just go into the feature store, fetch those features, and use it, rather than trying to do all of those processes again. It also helps from different teams redoing feature engineering, and they can just go in and use it from the feature store rather than doing that process again. Next is Vertex AI experiments. So this makes tracking, analyzing, and discovering different run experiments very easy. Vertex AI pipelines. So this is the primary part that creates your ML workflow. So these pipelines, they also help to automate, monitor, and also govern your ML systems. Another feature within Vertex AI is AutoML. So this feature can be used to create ML models without using any code. So depending on the type of problem you have, you specify like an objective or task that you have, whether it's a type of problem it is, whether it's classification, multi-classification, or a regression problem. And then from there, you basically define certain criteria like a metric that you want to minimize or maximize. And then depending on those, it goes ahead and builds a model up for you. So it's a great feature if you've never really used code before to build ML models. It kind of takes care of everything on the back end and creates a model that best suited to your different parameters that you've provided. Vertex AI Vizier. So this is a tool that helps to tune hyperparameters in ML models. So currently, sometimes if you're working with a model, in order to improve accuracy, you might want to try different hyperparameters for the model. So whether it's decreasing the learning rate or if you want to add more estimators in a random forest model, and many different things you can tune within a model. So rather than doing a manual process or writing some sort of for loop that's using different numbers, you can use this, which basically you define your scope of the parameters that you want to tune, and you define the certain criteria in terms of what the different ranges are. And then from there, it basically just goes across those different selections and it trains many different models, and then it gives you the best one, depending again on a certain type of metric that you want to minimize or maximize, whether that's accuracy or your loss. Vertex AI Prediction. So this is what actually deploys your ML model for online serving. This tool also offers built-in tracking to track your model performance. You can also go ahead and see how people are interacting with your model, how many hits you're getting, requests, or if there's any errors when the request is sent for prediction. And finally, Vertex Explainable AI. This is a really cool feature. This really helps you understand the outputs of the model better. It offers a more detailed evaluation metrics, and you can also get feature attributions from this. So it can tell you like how important each feature is for a certain prediction that is made. So now we'll go into the demo. So this is the Vertex AI dashboard over to the left. So I'll begin today's demo by just going through the data set. So we'll go into the data set, and we already have a data set which is loaded. So this is our data set. Here we can see a quick summary of the data set. We can see how many columns we have in total, 27, 20 are float, 7 are string. We can see total rows. So this data set is actually sourced from BigQuery, so it's telling us where it's from. This is the location of our data set. And we can see the different columns we have and the names. And we can also see if any were missing. In our case, there are none missing. So here in this data set, our observations are comprised of customer information, which includes like some general information, like education level, age, sex. And then it goes on and also has like history of payments, bill amounts, as we can see, and also previous payment amounts. So payment amounts. And our target variable in this data set is the default payment next month. So here in this data set, we're basically trying to predict whether or not a customer will default on their next month's credit card statement. And so this is a binary classification problem that we'll be doing in this. So this is the data set we're using, and our problem is a binary classification one. So now let's move on and let's just go to training. So the first step would be, once we've imported the data set, we would go in and we would train a model. So there's two ways of doing this. As I've mentioned before, we can use AutoML. So to use AutoML, we've already trained up an AutoML model, and we've done custom training. So we've done both ways that you can use Vertex AI. So first, I'll just go through AutoML. So this job was basically done by specifying a task and a target column. So here our task was classification. Our target column was the default payment column that we specified in the data set. So by supplying it that, it was basically able to generate this model, which it generated many different models, and then it picked the best one according to the precision. So we can see that this did take quite some time because it was generating many different models. And then we can go in, and once we've gone into the model, we can see that it's saved this model under our models dashboard. We have some quick statistics about the model, how it's performing. So we have precision recall F1 score. We have different graphs like the PRC curve, RLC curve. This is another cool feature, which is precision recall by threshold. So depending on your type of your specific problem, you can play around with the different thresholds. So currently it's set to 0.5, but say if you wanted to, if you needed a higher recall or a higher precision, you can change this threshold, and then you can also see how the model performs. We also have a confusion matrix down here and also some quick statistics on feature importance. So this was AutoML. This is what it had generated. So this is using no code. Next, we'll move on to the custom model. So the custom model was built using the Vertex AI workbench. So here we can spin up a compute instance and then open Jupyter Lab. So here we already have an instance running. We can see the machine type, the environment. Since we were using scikit-learn, we chose the environment to incorporate scikit-learn. You can also use TensorFlow, PyTorch, or a different framework, that whatever you're comfortable with. Going into the Jupyter Lab, here we have our Python training script. So this was the script we used to train our model. We're using a gradient boosting classifier. Once we've created the model, done some feature engineering, we can save this model back into GCP. Another thing that we've done here is we created a Docker file. So this Docker file was created because it builds an isolated environment for us to run our training code. This Docker file creates a container, which then we can register back onto GCP's container registry. And then when we are training the model, we can go ahead and we can import that this Docker container that we have already created, and we have tested our training code on it. And then we can use that for our training pipeline. So ensure that our training code runs and there are no errors that we are getting. So we'll go back into Vertex AI and we'll go into training. So here we can see this was our training job that we had run. We can see that the custom model took only 5 minutes to create. It was a custom training pipeline. So going into here, it takes us to our model. So here we can see that this is our model, and we can go ahead and now see like the next steps. So once you have created your model is saved under it's coming under your dashboard of models. You can go ahead and deploy the model. So we can see that creating an endpoint is pretty easy. It's a UI you can use right here. You can also do this through code, whichever way you prefer. So we've already deployed this model as well. So this is our endpoint for the model. So I'll just go into this. And here we can see that this is our endpoint. So this is just showing how the endpoint is behaving. So we can see different metrics like predictions per second, prediction error percentage, requests per second, and then also the response codes that we're getting, latency, model latency. This is since we haven't really interacted within the past hour, there's nothing to show here. But if we were to click past couple of days, you can see there is some hits that it took since we were interacting with it. And so this is a good way of just keeping track of how your model is handling traffic that is coming in. There's also more logs that we can see if there were some errors that we were getting. So moving on, now we'll actually show you a lightweight web app that we built to show interaction with using the model and actually interacting with a model that has been deployed into production. So we have this lightweight web app, and I've already pre-filled the values just for the sake of time. So here we can see that we supply it some general information, the repayment history, the billing history, and the payment history for the past 6 months. So these are just values that I took from the data set for 2 different customers. So I will do 2 different times. Also, this limit balance represents the limit balance of a credit card. It is quite high because this data set is based out of Taiwan. So this is a new Taiwan dollar or Taiwanese dollar. So it's not $320,000. It's Taiwanese dollars. So that's why it's quite high. And also for these columns here, like these features like sex, education level, marital status, you can see that these are actually integers because we've already encoded our string values and we've already mapped them to integers. So the model is going to take in these integers and it'll understand what those are mapped to. So once we filled out all of the information, we submit, here we can see that the model is predicting that the customer is not expected to default. Before I do that, just wanted to take a look. As we can see, these numbers quite low according to the limit balance, like limit balance quite high, but this person has been basically, history has been not as high. Their payment history has been also close to what they've been spending. Here you might see these negative ones and zeros. This basically means -1 means that the person is paying their credit card bill ahead of time. 0 means on time. And then if there's any positive integers, that just represents how many months it is late. So now we'll take a look at the second person. And here we can see that their limit balance is less than the person before. We can also see that here this month they've paid their bill twice as late. And we can also see that they're spending close to the limit while not really paying as much. So here our model is saying that the customer is expected to default. So that's what we're getting back from the model. So this was just a quick demo just to show how you would interact with the endpoint. You're sending it some information, and in input it is basically giving you back an output. However, in a more involved automation process, sending a request to the model will be part of a larger pipeline, while there are other certain processes that will depend on it. For example, like if there's a credit card company that gives like variable interest rate, use this model as like a part of a larger pipeline where it interacts with the model with like some customer information, and then depending on the response that it's receiving back on how probable the customer is to default or not pay their next month's payment or something like that, it might increase or decrease that rate. Just an example, but there's many other use cases for this. So this was just a quick demo that we put together on Vertex AI. I still haven't touched on many different key features that I mentioned earlier, such as like the feature store, the Vertex AI Vizier, which tunes your hyperparameters, as well as explainable AI. So like explaining why the model is making that prediction. So kind of seeing like which features are playing a role in that. We just wanted to talk about some key takeaways we had while working with Vertex AI within GCP. So there were many features that make handling the data science lifecycle much easier. So now we'll just talk about some of those key features that we found. So the first is that it is a unified ML platform, so everything is in one consolidated space. So Google has brought together all of its ML and AI APIs all together under one. As Scott was showing that the list of the developer cheat sheet, and it had all those different services under AI ML. It's basically brought together all those APIs, and it's all under one place now. Before they were all different APIs, whereas now everything's all connected and in one. So this helps to build, track, and monitor the different stages within your data science lifecycle. And another big thing is that it can also help teams collaborate much easily. So rather than some different teams and different people within teams building custom models or building models on their local machines, you can build it in this cloud environment where everything is in one place. So that way that if there's any updates that are made to notebooks or models or pipelines that are saved in real time, and they're all saved under the specific projects that you specified for. The second thing is that models can be built without code and with code. So as we've seen, we showed an example of an AutoML model, and then we showed the custom model that we had built. We can see that there's high flexibility in which way you want to go. So you can choose the AutoML version where you specify certain parameters, what your task is, like your target column in this case, since we were using classification, and it basically built up a model. And then on the other hand, if you want to build something that is more robust due to the control of like customization, how you can really tune the model yourself, control it, what it's outputting, how it's understanding your data, that makes the model a little bit more flexible. So depending on the complexity of the problem you have, you can use AutoML. It might be a good solution for it, or you can also go the route of creating custom models. And then also custom models can be created using scikit-learn, TensorFlow, PyTorch, all of the major frameworks and libraries that are used to build custom models. The next is the Vertex AI Workbench for ad hoc models. So this is great if you just wanted to try some sort of concept or some sort of just quick seeing if this model or how a model works, training up something quickly. Vertex AI Workbench uses compute instances, so you can also scale your development. If you're trying to build a large custom model, it'll also scale those instances, and you can use GPUs along with the CPUs, and it'll really benefit in training time rather than doing it locally. Another thing is creating training pipelines. So using containerization. So you can isolated environments can be built to ensure that versioning for packages and the consistency for the OS is present. So this also eliminates like the dependencies that your model or your training code might have on certain environments and certain versioning, like versioning of packages. So that way that your training pipelines, they're more versatile and you can basically run it on any instance. So anytime you're training, you're doing a training job, what Vertex AI does is it creates a compute instance, and it's like a virtual machine, and it basically runs your code on that virtual machine. So by incorporating and utilizing containerization, you're making sure that no matter which virtual machine it's spinning up, so no matter what size or whichever region it's spinning it up on, you're ensuring that your code will run on that virtual machine by making sure that you're using a container. And this is something that you have to do when you're doing training. You need to have either like a custom container or a container that it provides, just to make sure that your code is able to run on different environments. And then finally, models can be logged and tracked and deployed very easily using Vertex AI. So as we saw, once the model was trained, it was saved within our model's dashboard. We were able to basically deploy it to an endpoint, and that is serverless. So it's not you're not using a instance or your own or some sort of compute that's being run. It's all done from Google's end, so it's a serverless endpoint. It's a serverless service, and then you can create endpoints and to send like prediction requests, and then get back the response. As we saw, another feature is you can also monitor the model, so you can capture model drift if there is any. So model drift is if there is data that is not representative of what you had trained your model on, meaning like things are changing or shifting, your data is shifting towards something else, and you're seeing like a pattern. So whatever data you might have trained your model on 6 months ago is not valid anymore, and you need to retrain your model. So this is a way of recognizing that is by monitoring the model, and Google does that for you. You can monitor it, and then you can identify like data drift, and that way you can easily go ahead, retrain, and update the model to that same endpoint, or you can create a whole new model without going through the whole process again, since everything is already connected and it's all unified. Moving forward, so those were the key takeaways from GCP, and I just wanted to talk about how Thoroughgood can help. So we specialize in advanced analytics, data science, machine learning, AI, and more. We come from a business-focused perspective, and we tailor the best fit needs for our clients. So we do exploratory analytics to answer business questions, test hypotheses, and discover new models to drive business value. We do MLOps and DevOps, industrialization of existing use cases into production scale systems. We do analytics, architecture design projects, enable data science, ML at the enterprise scale. Data democratization enablement via like many different user empowerment projects and also like data lake offerings to achieve enterprise-wide data accessibility. We also do analytics empowerment programs to help promote like the adoption models and different tools. We use multi-cloud infrastructure enablement initiatives to fully realize the value of various cloud services. Finally, analytics strategy projects to advise people on the data tools and the different processes that might be needed to realize the value of AI and ML. We come to the end of our today's session. I hope that you all found this very useful. Once again, thank you for joining us and taking the time to join us, and thank you.